We spent some time now looking at the idea of integration as a way to find the area under the curve. And I want to take that idea and expand it a little bit and talk about the area of the region that's between two separate curves. Now, for the next couple of videos, I want to be concentrating on these two primary learning objectives. First of all, we want to find the area of a region between two curves using integration. And I want to find the area of a region between intersecting curves using integration. These two are exactly the same idea, but when two curves intersect, it brings in a slightly different twist that we need to consider. So first, let's start off with the idea of the area between two curves. If f and g are continuous on the closed interval from a to b, and g of x is less than or equal to f of x for all x on this interval a to b, then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b is given by the integral from a to b of, so g of x is less than f of x, so I'm going to take f of x minus g of x dx. That's how I'd find the area between the curves f of x and g of x between a and b when f of x is greater than or equal to g of x on this entire interval. Now let's take a look at a quick picture, and I think we could quickly see why this is reasonable. So I'm going to go from a to b, and let's just say that this represents f of x, and perhaps this is g of x. Let's just say they're equal at some point and then they come back down. So this is g of x. Now, if I simply integrate from a to b of f of x dx, what I'm going to get is this entire area underneath f of x, which is what you would expect. That's exactly what would happen if I just said, hey, integrate this function from a to b. But what I'm really interested in is just the area between f and g. So what I really want is just this area right here. So in order to get that area, what I'm going to have to do is I'm going to have to subtract off this bottom piece. And this bottom piece is in fact the integral from a to b of g of x. So if I think of it this way, I could actually rewrite this as the integral from a to b of f of x dx minus the integral from a to b of g of x dx. And that's exactly the way I explained it. But I can combine these, like the first form that I have it, or I could break it up in the second form. Whatever pleases me, whatever, when I look at a function, whenever I look at a problem, whatever way it makes more sense to me to attack it, I can do either. But both of these would describe this area that I hash marked here in the red. So that's going to be the basic idea, the basic formula, the basic thought process that we will go through when we're trying to find the area between two curves. Now, to point out one more thing here just quickly, notice right here I made them equal. So this is the point where they intersect, but it still satisfies this condition, because this condition said g of x is less than or equal to f of x for all x. They didn't switch places. The switching places when g of x at some point where they intersect becomes bigger than f of x, that's going to take a slightly different twist, and that's what this is actually making reference to. And we'll talk about that in a little bit.